Financial algebra, we are going to cover 11.1, which covers utility expenses. So this whole unit, Unit 11, is really, really helpful. Every one of us is going to have to pay for utilities in our life. So utilities include electricity, so like PG&E, your gas, water, heat, air conditioning, water, trash, etc. Those are utilities. So we are going to go over how to calculate that and some terms that are being used. So first of all, you're going to see this acronym KWH, and that refers to the kilowatt hour, and that's how you measure energy that's being used. So number one states that the difference in light bulbs, they came out with some energy saving light bulbs. So LED light bulbs are replacing incandescent because they use less energy. So the LED cost $1.32. The incandescent costs $6.09. How much could be saved by year if we used 25 LED light bulbs? So how much could be saved? Well, let's figure out $6.09 times 25. And then we're going to subtract the cost of an LED. So this is for the incandescent, that's a regular light bulb. And this is the cost of electricity for an LED. And we're going to look at how much money can be saved. So if I enter $6.09 times 25, I get $152.25. Minus, if I multiply my LED, I get 33. So I would save $119.25 by switching to LED light bulbs. And we've personally done that. It saves us on our energy bill. All right, PG&E or whatever energy, Edison, some of the companies use meters. And so these are meters. And how we read a meter is we're going to use the lower of the two numbers that the dial is in between, except if it's between 0 and 9, then you use 9. So we are going to read this. How many kilowatts of electricity are indicated? For this first one, it's because it's between 4 and 5, so use the lower of the two, so 4. This next one, it's between 6 and 7, so we use 6. Here it's between 4 and 5, so again 4, 6, and the lower of the two there is 2. So I would write 46,462 kilowatt hour of electricity. Okay. Number 3, a certain guitar amplifier requires 200 watts when it's being used. How much would it cost to run for 55 minutes at a cost of 11 cents per kilowatt hour? So we have to do a lot of conversion here. First, I need to figure out how much of an hour I'm using. So 55 minutes out of, there are a total of 60 minutes in an hour. So that gives me 11/12, or if I enter that in the calculator, 11 divided by 12 is 0.92 of an hour. So that's super important. Then I have to figure out my watts per hour. So I would multiply 0.92 times 200 watts. So here's my hour times my watts. And that gives me 184 watt hours. Now I have to convert this to kilo. And kilo is 1,000. Like kilometers, or kilometers means 1,000 meters. So kilo refers to 1,000. So I'm going to divide my 184 by 1,000 in order to convert it to kilowatts. So that gives me 0.184 kilowatt hours, or I could put 0.184 kWh. Okay? Now I'm going to take this and multiply that by the 0.11 cents, and I get in dollars 0.02024. Now because this is in dollars, I can then convert that to cents. So this would be about 2.02 cents per kilowatt hour. Next is another meters. So pick the smaller of the two. So because this is between 5 and 6, I pick 5. 3 and 4, so the smaller. 6 and 7. 0 and 1, so 0. And between 7 and 8, 7. So I would have 5,367. Whoops. And sorry, CCF means 100 cubic feet. So because this is 0, I'm just going to disregard that number. Next, oh, sorry. I think it should look like that. Next. All right, so again, the Simpsons' previous water bill showed a meter reading of 433. Below is their current reading. What should their next water bill be? So first I have to determine, okay, so between 0, that would be 0, 5, 6, 3. So 563 minus 433. That tells us our usage. So 563 minus 433, I get 130. And then I'm going to multiply by the 91 cents. And our new bill is $118.30. And sorry, I need to edit that on my paper really quick. Sorry. Give me 2 seconds. On my notes, I forgot to subtract the 433. Next, the Robinsons' old dryer cost them $455 per year to run. The new one they purchased for $940 will save them 18%. So let's talk about our savings. $455 minus the 18% of $455, because I'm figuring out how much they would save. So instead of spending $455, they should be saving, actually I only need to calculate, I don't need to know their new bill. I'm going to be figuring out savings. So 0.18 times 4. So this new dryer should save them $81.90 per year. But they spent $940 on it. So when will these become equal? When will the amount they paid times their savings, in what year will it pay for itself? So I have to divide, and I got 11.5 years. So it's going to take a while for the cost of this new dryer to make up for their amount of savings. So number 7 talks about balanced billing. Balanced billing is when they take last year's amount and they basically create an average so that you're paying the same amount every bill. So we did this for PG&E. They took last year's amount, they averaged it out. That way we could pay the same amount per month. It's easier to budget that way. So what was their monthly payment last year? So $32.50 divided by 12, and I get a monthly bill of $270.83, because this is the year amount divided by 12 months. During the year, they actually use $37.66. So $37.66 minus $32.50, because they have to pay the difference at the end of the year. So I get a difference of $516 that they're going to have to pay at the end of the year. Number 8, last winter, the family used 431 gallons of heating oil at a price of $4.12 per gallon. If the price increases, what is their approximate heating expense for the year? So let's first take into consideration the increase. So $4.12 times 0.0825. And then I'm going to add that to my original price, right, because it's an increase. And so I get that the new price will be $4.46 times the gallons they used, and their new bill for the year is $1,922.26. It says around to the nearest tens. Tens is right here, so 1920. Next, a light bulb requires 60 watts to run when it's turned on. If a light fixture requires 3 of these bulbs, so 60 watts, 3 of these bulbs, it's left on for 4 hours per day. How much is wasted each year? So let's figure out. I have 60 watts times my 3 bulbs, and I leave it on for 4 hours. And so I get 720, and that's per day. Then I have to figure out that I then have to convert it to kilo, so 720 divided by 1,000, and I get 0.72 kilowatt hours, but then this is per day. So there are 365 days in the year, so this would waste 262 kilowatts per year. Next, Mr. Denton's last water bill was $109.56. The previous reading was $12.09 and the present reading is $14.17. What does his company charge for 100 CCFs? Cubic feet of water. Cubic feet, 100 cubic feet, remember, is what CCF stands for. So let's see here. His last bill equaled $12.09 times whatever they're charging per CCF, like $12.09 times the number of cents. So I need to figure out how much they're charging him per CCF. So if I divide both sides by $12.09, I get that they're charging him 0.0906 cents. So then multiply that times his current use, and I get that his bill should be $128.41. Moving on. A water bill lists a current reading of $45.01 and a present reading of $49. The water company charges 86 cents. So let's find the difference, because they're just going to charge him the difference of what he, between the two. And I get that he used 470 CCFs. And then you take 470 times the 86 cents, and I got $404.20. Number 12, 1 watt hour is equivalent to 3.14 BTUs. How many watts does it require per hour? So I have 1 watt hour is equivalent to 3.413. So I have watt on the top and BTU on the bottom. And I'm going to set this proportional. They said I have 10,000 BTUs, so how many watts? So I'm going to cross multiply. So I get 3.413x equals 10,000. I divide by 3.413 and I get 29.2997. But they said round to the nearest 100. So that would be here. So that would give me 2,900 watts. Express your answer in kilowatts. So I have to divide by 1,000. So I get 2.9 kilowatt hours. Last part. So if I run it, I have 2.9 kilowatt hours, but I'm running 15 hours a day, and it costs 12 cents. What is this cost if I run that for 60 days? So I have my kilowatt hours times the number of hours times the money times the number of days, and I get $313.20. I said to round to the nearest dollar, so that would be $313. And that should cover what you see in your homework.